Whispering is the natural choice of communication when one wants to interact quietly and privately. Due to vast differences in acoustic characteristics of whisper and neutral speech, there is a drastic degradation in the performance of whisper speech when decoded using ASR system trained on neutral speech. Recently, to handle this mismatched train and test scenario, denoising autoencoders based mapping from whisper to neutral speech features has been explored. Here, mismatch scenario means AM is trained on neutral speech but decoded on both whisper and neutral speech. DA improves the recognition accuracy for whisper speech. To improve further, we propose to explore joint VAE based mapping. We cannot map features from one domain to another domain using conventional VAE because input of encoder and output of decoder must be same, as can be deduced from its elbow equation. This is handled in joint VAE by learning a joint distribution of whisper and neutral speech features for a common latent space. In the architecture, input to encoder is filter bank features of whisper speech. In lower decoder, same whisper filter bank features are predicted. In upper decoder, time-aligned neutral speech features are predicted. Joint VAE is trained using the laws described in the equation L3. The first and second term are reconstruction laws for whisper and neutral speech respectively. The last term denotes scale divergence between posterior distribution QZ given X and prior distribution. Training joint VAE requires time-aligned parallel data for whisper and neutral speech. We use WTIMIT dataset for our experiments. In this dataset, recordings for both whisper and neutral speech is available for same text, but they are not time-aligned. We propose an algorithm to time-align the frames using Sinon alignments. Joint VAE is trained on the final frame sequence yielded by the proposed algorithm. At test time, whisper features are first passed through trained joint VAE to predict corresponding neutral speech features. These neutral features are used to predict log likelihood using acoustic model previously trained on neutral speech. From table 1, we can see that the ASR accuracy degrades drastically for whisper test set compared to neutral speech test set. DA based mapping improves the performance significantly, but there is huge gap in word error rate on these test sets. The joint VAE based mapping improves further on top of DA. Overall, we achieve an absolute improvement of 5.52% in word error rate over DA. Final loss for joint VAE involves 3 hyperparameters, as can be seen from the last equation L3. We experiment with different values of these hyperparameters and report the results, which can be seen in table 4. Overall, we achieve significant improvements compared to both the baselines. As clear from the results, joint VAE based mapping is able to encode characteristics of both whisper and neutral speech features effectively in latent space. Thank you.